So today's topic is forces in two dimensions, which means forces that are not specifically in the same direction as the object is moving in. So that includes examples such as these two down here. This one is a ramp, or in physics language, an inclined plane, in which an object is lying on top of an inclined surface that has certain inclination or is slanted, and the object is either going to start accelerating downwards, or if friction is big enough, it's going to stay still there because of friction. Or in the second example, there's an object on the ground and a person who's taller than the object is going to pull on it with a string or with a rope at an angle. So the object is going to move horizontally to the right, but the person is pulling a little bit upwards in a diagonal force. So the way that these problems are solved or analyzed in order to determine the acceleration of the object that is moving is by following this sort of recipe, or these rules. So the first and most important one is that they must be solved by components. Because we're talking about two dimensions, we are going to have to use the vector components information that we learned about before. So the first thing that we have to do for any example is to draw a free body diagram. And we're going to do that in specific examples after this, but just in general, draw a free body diagram of the object that the forces are acting on. Then the second rule, or the second step, is to identify the forces that are at an angle with respect to the direction of motion. So for example, in this pulling object example, the object is going to be moving to the right, but the force is at an angle with that. So there's a small angle here between the force and the direction of motion. So the third rule is to analyze the two directions separately. So by two directions we mean, in this example, horizontal and vertical. So we're going to have to analyze all of the horizontal forces and movement and all that apart, completely separate from our analysis of the vertical forces in vertical motion. And the fourth step is to calculate the acceleration in each of the directions. So one of the accelerations is going to be 0. In this example, the vertical acceleration is 0 because the object is not moving up or down. It's only going to be moving to the right. So one of the accelerations is always 0, in this case the vertical one, and the other one is what we're looking for in the example. So here in the second rule, when you have those forces that are acting at an angle, you divide them into components. So what that means, as we've seen before, is, for example, this diagonal force, we're going to have a horizontal component that goes in the right direction and a vertical component that goes upwards. So those are like the two new forces that we're going to use instead of the diagonal force in step 3 of analyzing the two directions separately. So for this to make a little bit more sense, I'm going to solve some examples, specific examples with numbers to make it a little bit more clear after this.